This lesson is part 2 of section 9.4 on factoring out the GCF. So our target for today is to continue to factor out that greatest common factor. It's just the problems are going to get a little bit more tricky today. We're going to start though with some review problems, very similar to what we did in class today. For the first example here, when I look at both terms, I realize the greatest common factor here is 3. When I pull out that 3 from 3a, I'm left with a, and when I pull out that 3 from negative 21, I'm left with a negative 7, so I'll write minus 7. Now for number 2, when I look at the numbers here, 8 and 12, although they have a 2 in common, remember we're looking for the greatest common factor, so in this case I would use 4. The greatest common factor here would be 4, and once I pull out that 4 from 8x, I'm left with 2x. And when I divide 12 by 4, I'm left with a positive 3, so I'll write plus 3. Then finally for number 3, it looks as though 15 is going to be the greatest common factor between both of these terms. So when I pull out that 15, from the first term, I'm left with just the y here. And then remember, you don't want to just leave it as 15 times y, because we need this second term. Now, when we divide negative 15 by 15, it's not 0. We're going to be left with a 1, and in this case, it's a negative 1. So make sure you write minus 1. You always need a placeholder for that second term, because again, if you multiply that out, if I only had the first term and I didn't have this minus 1 here, I'd be left with just 15y, which is not the same as that original expression. So we need to make sure that we always include a placeholder for the term, even when it divides out evenly. Okay, so we have 15 times y minus 1 left over. All right, so now we get into GCFs that are a little bit more complex than just numbers that we were dealing with earlier today. So a GCF doesn't always have to be just a number. When you factor using the GCF, you can take out a number, you can take out a variable, so that's where it's differing from what we did today. You can also take out a negative sign, which is something we'll talk about more later on in the chapter. We typically will always do this when the lead coefficient is negative, okay? And then, of course, you can take out a combination of all of the above. So the big idea here is that now instead of just being a number, we can take out a variable, and again, a combination then of both a number and a variable. So let's try with our very first example here, number 4. We're taking out the GCF of 2x squared and negative 8x. Now hopefully, since you guys have had a lot of practice with this, right away you'll recognize that for the number part, a 2 is the GCF between 2 and 8. However, we now have a variable part for both terms here. We have x squared here, and we have x here. Now these two terms share a greatest common factor here of x. So an x can be pulled out along with that 2. So 2x is now on the outside of my parentheses. Now if I take both terms here and I divide it by 2x, that would mean I'd be left with just 1x in the first term. And if I divided negative 8x by 2x, the x's are going to cancel out and I'm left with just 4. So I'm going to write this as minus 4, since negative 8 divided by 2 would be negative 4. We can always double check that our answer is correct. We're going to distribute this back. If I distribute that back, I would get 2x to the second power, because I'm multiplying x times x. And then when I distribute 2x to negative 4 here, I'd end up with just negative 8x. So I know I did it correctly because it matches the original expression. Now when we look at number 5, first I want to look at the number part. So here there's a 1 out in front and a 2 here. The GCF here is just going to stay 1, so I don't have to pull out a positive 1. You can if you want, but typically you will never see me pull out a 1. So in this case, there's no number part for the GCF that I'm going to pull out. However, for the variable, here I have a squared, and here in this term I have an a. So I can pull out at least one a from both of those terms. So I'm going to take an a and put it on the outside of the parentheses, and then I'm going to divide each term by a. So left over here, a squared divided by a, well, one of those a's is going to cancel in the top with the bottom a, and we're left with just an a. When I take negative 2a and I divide it by a, those a's are going to cancel and I'm left with negative 2. So my final expression here, when I factor it and take out that GCF, will be a times a minus 2. Now for the last problem here, number 6, again we're going to take it one piece at a time. Let's look at the number part first. When I look at 7 and 7, obviously the GCF here would be 7. So I'm going to pull that 7 on the outside of the parentheses. Then I'm going to look at the variable part. Here I have a y squared, here I have a y. So again, in common, I can pull out at least one y from both of these terms. So if I pull out that y, Now I'm going to take each of these terms and divide by that GCF 7y. So I'm going to set up my parentheses first. So I'm going to pull out that 7y. The 7's are going to cancel. Y squared over y also cancels and leaves me with just 1y in the numerator, so 1y on top. And then when I divide 7y by 7y, again, both the 7's and the y's cancel. Remember, from our last example up here, we can't leave it, with just a 0 there. We have to make sure we have a placeholder here. In this case, it's going to be 1. 7y divided by 7y is positive 1, so it's going to be plus 1. And there is my final answer. Again, if I want to distribute it back out to make sure it's correct, 7y times y is 7y squared, and 7y times 1 is positive 7y, which is the original. Once I erase here, you can see it. It is the original expression that we started with. Okay? All right, so tomorrow we're going to get a lot more practice, and we're going to ramp up the difficulty a little bit because we're going to have more than just one variable. Here we did some pretty basic examples. If you notice that each time here I did x squared and an x, here was a squared and a, here was 7y squared and y. Later on tomorrow we're going to see things like a cubed minus a squared, and we're going to try to find the GCF between those. So make sure you understand at least these basic 3 problems. If you don't, go back and rewatch a little bit. Come into class with questions, and then you should be good. All right, nice job. See you tomorrow.